Las Vegas is facing a new, silent catastrophe, a threat that does not drain a lake but boils the air. For a century, the city survived the impossible by conquering the desert's thirst. Now, it must survive the desert's fury. The enemy is no longer a lack of water, it is an abundance of heat. And the city itself has become the perfect weapon for its own destruction. The nights are no longer bringing relief. Sunset arrives, but the suffocating heat remains trapped in the concrete and asphalt. Not a warm evening. A thermal prison. This is not a weather forecast, it is a system failure. So a new generation of scientists and engineers are fighting a battle not for water, but for shade, for a breeze, for the simple memory of a cool desert night. They are trying to repaint the city, to tear up its very foundations, to relearn how to build in a world that is fundamentally changing the rules. But here is the secret they are uncovering. The city's greatest defense against the heat, air conditioning, has become its greatest accomplice. It is a feedback loop accelerating the crisis every single hour. So, the terrifying question is no longer about finding water deep underground, it's about whether a city made of heat-absorbing stone can escape being baked alive from the inside out. Let us know in the comments, have you ever been in a city that seems to refuse to cool down even hours after sunset? We dig into stories like this every week, stories about the immense challenges and audacious engineering shaping our survival. An incredible number of people who watch our documentaries aren't subscribed. If you find this kind of deep dive valuable, do us a favor and hit that subscribe button now. It is genuinely the most important way to support what we do, and it ensures you will not miss what is coming next. It's a small click that makes a monumental difference. Let's begin. Las Vegas was built on a promise the desert never actually made. The promise was that the heat, however brutal during the day, would always retreat at night. For decades it did. The arid climate, the low humidity, the clear skies, they were a perfect combination for what scientists call nocturnal radiative cooling. The ground, baked by the sun all day, would radiate its heat back into the vastness of space. Temperatures would plummet. A 110-degree afternoon could give way to an 80-degree evening. This daily thermal rhythm was the unspoken foundation of the city's existence. It was the crucial off switch for the environmental stress. Without it, the city is a 24-hour oven. That rhythm is now broken. The off switch is gone. Las Vegas now endures nights that are, on average, more than 10 degrees Fahrenheit warmer than they were just a few decades ago. The problem is not just the record-breaking daytime highs, it's the astonishingly high nighttime lows. Days of 115 degrees are followed by midnights that fail to dip below 95. This is the signature of a phenomenon known as the urban heat island effect, and Las Vegas is a textbook case. Worse than a textbook case. It is a terrifying real-world example of the theory pushed to its absolute limit. Think of a city as a giant rock. During the day, the sun bombards it with solar radiation. In a natural landscape, soil, grass, trees, a significant portion of that energy is reflected, or it's used in processes like evapotranspiration, where plants release water vapor actively cooling the air. A city does the opposite. Dark asphalt roads, black tar roofs, concrete buildings, glass towers. They are all materials with low albedo, meaning they reflect very little sunlight. Instead, they absorb it. They spend 12 hours a day drinking in solar energy, storing it like a massive thermal battery. Then the sun goes down. The process that should cool the city begins, but it fails. The tightly packed buildings block the wind that would otherwise carry heat away. The sheer mass of superheated concrete and asphalt begins to radiate its stored energy, not up into space, but sideways, into the streets, onto pedestrians, into the windows of neighboring buildings. The city's own geometry creates a canyon of trapped heat. The air is not cooling. It is being actively reheated from below and from all sides by the very infrastructure of the city itself. This is the thermal prison, and Las Vegas built its own walls. It was not a conspiracy. It was a consequence of relentless, unthinking growth. Consider the city's expansion. In the 1970s, Las Vegas was a sprawling but relatively low-density town. By the 2000s, it had become a dense urban core, surrounded by an ocean of suburban sprawl. Every new road was a dark, heat-absorbing river of asphalt. Every new parking lot, and Las Vegas has an astronomical amount of surface parking, was a black thermal mirror pointed at the sky. Every new building added to the mass of concrete retaining daytime heat. Planners modeled traffic flow, population density, and water consumption. They did not model thermodynamics. They did not account for the cumulative thermal load of 1 million tons of concrete. The result is a city that now has two distinct heat island profiles. The daytime effect is bad enough, but the nighttime canopy layer heat island is the true killer. This is the bubble of superheated air that gets trapped between the buildings from the street level up to the rooftops, while the air just a few miles away in the open desert is rapidly cooling as nature intended. This urban bubble remains stubbornly, dangerously hot. For the human body, this is a profound shock, an unbroken assault. There is no recovery period, sleep is disrupted, the cardiovascular system remains under constant strain. For the elderly, the young, and those with chronic illnesses, it is not an inconvenience. It is a life-threatening condition, a silent, creeping disaster that unfolds not in a single dramatic event, but hour by hour, night after night. It's a startling realization watching a city's own design become its greatest liability. Let us know in the comments, what part of your own city feels like it was built for a climate that no longer exists? The city has always had an answer for the heat, a brute force, quintessentially American solution: air conditioning. It is ubiquitous, non-negotiable, and woven into the very architecture and psychology of southern Nevada. New homes are not built with cross breezes in mind. They are built as sealed boxes, fortresses against the outdoor environment, entirely dependent on mechanical cooling. Commercial buildings, casinos, convention centers, they are monumental structures of refrigerated air. The Bellagio's conservatory, a 14,000-square-foot glass atrium filled with live plants, is kept at a comfortable 72 degrees Fahrenheit, even when it is 117 degrees on the strip just feet away. This is not just cooling. This is the defiance of physics. And it comes with an almost unimaginable cost, not just in dollars but in heat. An air conditioner does not destroy heat. It moves it. The heat pump in every single AC unit, from a tiny window box to a massive industrial chiller, works by taking thermal energy from inside a building and ejecting it outside. Multiply that by over 780,000 households. Multiply it by the colossal cooling systems of the mega resorts, each one capable of cooling a small town. The collective result is that the entire city is pumping billions of BTUs of waste heat directly into the urban canopy layer that is already struggling to cool down. It is a vicious, self-perpetuating cycle. The hotter the city gets due to the urban heat island effect, the more people rely on air conditioning. The more they run their air conditioning, the more waste heat is pumped into the city, which in turn intensifies the urban heat island effect. It is a thermal death spiral. The very tool used for individual survival is accelerating the collective crisis. This places an almost impossible strain on the region's power grid. During the peak of summer, air conditioning can account for up to 70% of the Las Vegas Valley's total electricity demand. The utility, Nevada Energy, has to plan for these immense seasonal spikes, building and maintaining power plants that may only be needed for a few hundred hours a year, a hugely inefficient but necessary expenditure. The numbers are staggering. On a hot summer day, the power demand for the city can exceed 8 gigawatts. That is more electricity than is consumed by the entire country of Iceland. It's enough to power 8 separate DeLorean time machines all at once. The infrastructure required to deliver that power, the transformers, the substations, the high-voltage lines, is itself vulnerable to the extreme heat it is trying to combat. If this breakdown of the hidden costs of cooling is eye-opening, do us a favor and hit the like button. And if you have family or friends living in hot climates, share this with them. It's a conversation that affects millions, and understanding the problem is the first step toward finding solutions. Transformers, the boring green boxes that sit in nearly every neighborhood, are not designed to operate in ambient temperatures of 115 degrees with no nighttime cooling. They are filled with mineral oil that dissipates heat, but when the surrounding air never cools down, the oil itself can overheat, degrade, and lead to equipment failure. A localized blackout during a moderate heat wave is an inconvenience. A cascading grid failure during a record-breaking multi-day heat event where nighttime temperatures stay above 95 degrees is a public health catastrophe of the highest order. It is the scenario that keeps city emergency managers awake at night. A city of 2.3 million people, suddenly without air conditioning, trapped in their superheated homes. The worst case has a way of arriving ahead of schedule. For years, the city's leadership saw the rising heat as an atmospheric problem, a matter for climate scientists. Now they understand it is an infrastructure problem, and just like with the water crisis, they are looking for an engineering solution. The battle has begun on two fronts, the surface and the sky. The surface war is a fight against absorption. The prime culprit is asphalt. A typical black asphalt parking lot can reach surface temperatures of over 160 degrees Fahrenheit on a sunny day. This makes it a perfect radiator, pouring heat into the air long after sunset. So, the city began experimenting with what is known as cool pavement. The concept is simple. Lighter surfaces reflect more sunlight and absorb less heat. In pilot programs, sections of streets and parking lots were coated with a specialized grayish-white sealant containing reflective pigments. The results were immediate and dramatic. Surface temperatures on the treated asphalt dropped by as much as 20 to 30 degrees. The sealant acted like a mirror, bouncing a significant portion of the solar radiation back into the atmosphere before it could be absorbed. The idea was promising. The execution in a city like Las Vegas proved maddeningly complex. The first problem was cost and scale. Treating the thousands of miles of roads and the hundreds of square miles of parking lots in the valley would be an astronomical expense, a public works project on a scale rarely seen. The second problem was durability. The reflective coatings were worn down by traffic, stained by oil and tire residue, effectively turning them dark again. The relentless desert sun itself caused some materials to degrade and lose their reflectivity over time. It was a solution that required constant, expensive reapplication. It was not a one-time fix. It was a perpetual, costly battle against physics and friction. Engineers then explored more advanced materials, permeable pavements that allow water to seep through. Cooling the surface via evaporation were a possibility, but in a city defined by water scarcity, using precious water to cool roads seemed like trading one crisis for another. They looked at asphalt mixes that incorporated reflective aggregates, building the cooling property into the road itself rather than painting it on top. These were more durable but also significantly more expensive than traditional asphalt, a hard sell for municipal budgets already strained. The Cool Pavement Initiative was not a failure, it was an education. It taught the city that there was no single magic bullet. Repainting the city white was a start, but it was not enough. The heat island was too powerful, the thermal mass too great. The second front of the war was the sky, or, more accurately, the space between the ground and the sky. The goal was to create shade. In a desert environment, shade is the most effective and lowest-tech form of cooling. The difference in temperature between a sun-drenched patch of asphalt and the shaded area beneath a tree can be over 40 degrees. The solution seemed obvious. Plant more trees. Create an urban canopy. The city of Las Vegas launched aggressive tree planting initiatives. They funded programs giving free desert-adapted trees to homeowners. They worked to line more arterial roads with leafy canopies. The goal was to fight the urban heat island effect one tree at a time. But here, the city's two existential crises collided head-on. Trees need water. In the driest city in America, a city that just spent $1.4 billion drilling a tunnel to the bottom of a disappearing lake, a massive expansion of the urban forest seemed like a paradox. The Southern Nevada Water Authority, the same agency that masterminded the third straw, had spent 2 decades convincing residents to tear out their water-guzzling lawns. Now, another branch of government was telling them to plant trees, which also require irrigation. The conflict was real, but the science was nuanced. Water managers and climate scientists began working together, a collaboration born of necessity. They realized not all water use is equal. Water used on a decorative lawn mostly evaporates under the sun, serving little functional purpose. It is a net loss. Water used to sustain a strategically placed tree, however, provides a measurable cooling benefit. The shade it casts lowers surface and air temperatures, which reduces the need for air conditioning, which in turn saves electricity. And saving electricity generated by power plants also saves the enormous amount of water those plants use for cooling. It was an elegant, integrated system. A tree's shade could, in a roundabout way, save more water than the tree itself consumed. The numbers started to make sense, so the focus shifted to the right tree in the right place. Not sprawling oaks or maples suited for wetter climates, but desert-native species like Palo Verde and mesquite, trees that are naturally drought-tolerant and provide dappled, high-quality shade. The mission became to create an urban forest that could survive on minimal water while providing maximum cooling. It was a delicate balancing act, an attempt to build a green infrastructure that respected the desert's limits. And yet, even this was not enough. Planting a sapling today provides a small patch of shade. It would take 20 years for that tree to grow into a meaningful canopy. The heat crisis was not 20 years away. It was here now. The city was adding trees by the thousand, but it was losing the war against the sun by the acre. The sheer pace of development, of new roads and buildings, was still adding more thermal mass than the new trees could possibly compensate for. Like the third straw, it was not a growth strategy, it was a survival strategy, and it was falling behind. And hey, I know we mentioned it once, but if you're still with us, learning about this incredible urban challenge, and you still haven't subscribed, now is your chance. We go this deep on critical issues every single time, and your subscription is what fuels it. Don't miss out on the next one. The failure of nighttime cooling is more than an environmental issue. It is a cascading threat to the very systems that allow a modern city to function. The vulnerabilities are hidden in plain sight. in the mundane infrastructure no one thinks about until it fails. Take data centers. Nevada, with its favorable tax laws, has become a major hub for data storage. These are massive, anonymous buildings housing the servers that run our digital world. They generate an immense amount of heat. They are, in effect, giant toasters. They rely on colossal cooling systems, 24 hours a day, 365 days a year. Those cooling systems, known as computer room air handlers or CRAC units, are themselves vulnerable. They are designed to operate within a specific range of ambient outdoor temperatures. When the night air never cools down, the CRAC units have to work harder, pulling in hot air and trying to chill it. Their efficiency plummets. Their failure rate increases. A cooling failure in a data center can cause servers to overheat and shut down in minutes, potentially wiping out data and disrupting services for millions. The cloud, it turns out, is terrified of a hot night in Las Vegas. Aviation is another hidden victim. Extreme heat affects air density. Hot air is less dense than cool air. For an airplane, this means the wings generate less lift during takeoff, and the engines produce less thrust. On brutally hot days, this density altitude can become so high that aircraft are forced to reduce their weight to take off safely. This means bumping passengers, offloading cargo, or reducing fuel loads, which limits their range. Phoenix's Sky Harbor Airport has had to cancel dozens of flights on a single day because the temperature exceeded the operational limits of some regional jets. They simply could not generate enough lift to get off the ground. As Las Vegas gets hotter, its role as a global travel hub is threatened by the simple physics of air. The problem is compounded when the heat lingers. Runways made of black asphalt retain heat just like city streets. A runway that hasn't cooled overnight starts the day already hot, reaching its critical temperature limits much earlier in the afternoon. The heat is shrinking the operational window for a multi-billion-dollar aviation industry. Even the architecture of pleasure, the casinos, is feeling the strain. The iconic glass facades of the Aria or the Wynn are architectural marvels, but they are also giant greenhouses. They are engineered with sophisticated reflective coatings and insulated glass, but under the relentless assault of a 115-degree day, they are still fighting a losing battle against heat gain. The cost to keep these glass towers cool is astronomical. That cost is passed on to consumers in room rates and resort fees. Quietly, the rising heat is becoming a thermal tax on the entire tourism economy. Hotel engineers who once planned for cooling system maintenance are now planning for full replacements, upgrading to more powerful, more efficient, and vastly more expensive systems, just to keep pace with the changing climate. They are in an arms race against the sun, and the desert is winning. The models are not ambiguous. Climate projections from multiple independent institutions all point in the same direction for the American Southwest: hotter, drier, and more extreme. The heat waves will become more frequent, they will last longer, and they will be more intense. The gradual warming trend of the past is being replaced by a rapid, non-linear escalation. What was considered a once-in-a-century heat event is now projected to happen every few years. The engineering assumptions that underpin the entire city, from the power grid's capacity to the air conditioner's design, are being invalidated faster than they can be updated. This reveals the deepest, most unsettling truth. The city's engineering solutions, however clever, are fundamentally reactive. They are chasing a problem that is accelerating away from them. Cool pavements, urban trees, more efficient air conditioners, they are all attempts to manage the symptoms of a crisis whose root cause lies far beyond the city limits, in the global climate system itself. Las Vegas is on the front line of a war it cannot win alone. It can harden its infrastructure, it can refine its building codes, it can plant 1 million trees, but it cannot stop the sun from getting hotter. It cannot force the nights to cool down. The ultimate nightmare scenario is the convergence of the city's two great crises. A multi-week, record-shattering heat wave occurs during a period of extreme drought. Lake Mead is at a critically low level. The hydroelectric power generation from Hoover Dam is reduced. The other power plants in the region which use water for cooling are also operating under stress. The electrical grid, pushed to its absolute limit by the citywide demand for air conditioning, begins to fail. A transformer explodes in one neighborhood. A substation overloads in another. The failures cascade. A significant portion of the city goes dark. In that moment, Las Vegas reverts to what it was a century ago, a collection of buildings in an unforgiving desert. But now it's a desert made hotter by the concrete itself, and the buildings are sealed traps with no breeze. In that scenario, heatstroke deaths would not be counted in the dozens, they would be counted in the thousands. This isn't science fiction, it is the logical endpoint of the city's current trajectory. It is the worst case, and the worst case keeps arriving ahead of schedule. Okay, I know, this is the third time I'm asking. It's starting to feel like a telethon, but honestly, hitting that subscribe button is the single best way to make sure we can keep making these documentaries. Think of it as your vote for more deep dives into the issues that truly matter. Thanks for indulging me. So, Las Vegas is not just a city in a desert anymore. It is a laboratory. It is a testing ground for urban survival in the 21st century. The lessons learned here, the successes and the failures, will be studied by cities around the world, from Dubai to Phoenix, from Melbourne to Madrid. The challenge is no longer just about growth. It is about endurance. The city that was built to defy nature is now forced to learn from it, to mimic its cooling strategies, to respect its limits. The effort is heroic. The engineers experimenting with road coatings, the urban foresters calculating the shade value of a single mesquite tree, the water managers balancing a tree's thirst against its cooling power, they are all fighting to retrofit a metropolis for a future that has arrived too soon. They are installing cool roofs on public buildings, updating building codes to require more reflective materials, and designing public spaces with shade as the primary consideration. They are trying to undo a century of thermal mistakes. But the city is also defined by its own momentum. The tourism engine demands spectacle. The economy demands growth. The dream of Las Vegas is one of limitless possibility, of conquering the desert, of building the impossible. That dream is now colliding with the hard reality of thermodynamics. The light from the Strip is visible from space, but so is the bloom of heat rising from its streets. Las Vegas mastered the art of bringing water to the desert. Now it must master the far more difficult art of letting the heat go. The battle is not for the soul of the city, it's for its simple physical survival. The strategies are in place, the science is understood, but somewhere in the heart of the city, in 1 billion tons of concrete and asphalt, the heat is still building, and the night offers no escape.